All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up kind of where we left off last night, although I have moved things on a little bit from there, so we'll kind of go over that as well. Tonight we're going to take a look at using multiple vertex buffers to solve a problem that we have. So we're going to get to that in just a second, but before we do, I want to just take a quick second to thank the supporters of the channel, beginning with our elite partner Javier Olazaron, followed by our partners Gerbolis Inc. and Matt Osgard. They are the highest tiers of subscription, over on YouTube memberships and Patreon, followed by the other supporters you see listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It's greatly appreciated and helps me cover the cost of running this channel, running the project. Things like software licenses, hosting fees, things of that nature. So it helps me out a great deal, and I really, really appreciate it. So thank you very much for that. With all that being said, I do want to just also take a quick second to thank you guys, the viewers, whether you're joining us on the YouTube side live or the Twitch side live, or if you're catching the VOD after the fact. Thank you guys very much for being here. I appreciate each and every one of you. So yeah, thank you guys very much for being here. Appreciate it. All right. From Lake, good to see you as well. Started showing 3 ads instead of 2. Yeah, I don't have any control over how many ads it gives you, but how am I doing? Did I have a good day? Yes, I did, actually. Thank you for asking. How about you? I did have a pretty good day. Appreciate that. Riacho, good to see you as well. Hello. Ruche with the dumpster fire. Yeah, so dumpster fire because I am getting a little bit of a late start tonight. I just had a couple things I had to sort out before I could start the stream, and, you know, sometimes it just pushes things back a little bit, but we will persevere anyways. So let me just take care of one more thing before we actually get started, and we will continue on from there. Okay. So, what we are going to talk about tonight is vertex buffers and vertex attributes, because that's what we're going to be working around tonight. And I've actually done some of this work off stream, but essentially, and we kind of briefly talked about this last night, if we take a look at the material standard skinned vertex shader, we've got these vertex inputs here. So these are all of our vertex attributes, right? So we've got what's typically thought of as our sort of vertex 3D standard, if you will, vertex data. So our position, normal, texture coordinate, color, tangent, right? Those are all the things that are, those are all the things that are considered part of a vertex 3D. So these are basically the things that we're going to use 90% of the time. And so we always just include them. And then we've got what we're going to call extended vertex data. And that is extra vertex data that's outside the concept of what we consider our standard. And so for animated geometry, we actually have a set of bone IDs and weights for particular bones that can have influence on various vertices as, you know, we kind of loop through them. And so what we're actually going to do is we're going to look at splitting these two, because right now we have to have a separate shader to handle animated vertices, right, that contain this extra data, and static, which only contain this. And so by actually splitting these out into 2 vertex buffers, we can basically say that we always want to use this one, whether it's static geometry or animated geometry. And then we can optionally use these. And then if we can essentially pass a flag into the shader that says whether or not we want to actually read from those or not, and go from there, right? So essentially the idea is we always bind a vertex buffer for this. So this is one vertex buffer. And then we'd have a second vertex buffer that would contain this data that would always be bound as well, but we not necessarily read from it, right? And so the advantage to doing that is we don't have to have two shaders to handle all this stuff. We can do it in one shader and just bind garbage to this if we're not going to use it, right? So that's the underlying idea here. And so I've actually started a little bit of the implementation of this. And so actually, if we go to the renderer front end and we go to initialize down here, I've done a little bit of renaming of things, but we essentially now have two vertex buffers and a geometry index buffer, right? And so what we're doing here is we're actually calling, and I'm going to go to the state here for just a second. So we're calling the one that we've been using up till now, we're renaming that to the standard vertex buffer. So that's the vertex buffer that always contains the data that we expect and no sort of additional data. And then we're going to have the extended vertex buffer, which is going to have, our bone weights and bone IDs, things like that. And there'll be other uses for this too. So terrain geometry will also be able to make use of this for terrain blending data. And so this is going to allow us to actually combine a lot of our sort of separate shaders that we have now into a single shader, and then just switch how we bind these two guys. And so that's kind of the idea that we're going to be switching to as far as that's concerned. So essentially, for right now, this should probably be, see if I can, that should probably be a smaller size. So essentially, the standard buffer is basically going to be a set number of vertex 3Ds, and that's mostly what we're going to put in there. It's not all we're going to put in there, but anytime we have sort of extended vertex data, that's going to be sort of the base. And then we're going to have the extended vertex buffer that's going to allow us to store some additional data in there. And so all the properties are basically the same. It's just we have, potentially different size for that. And we've obviously named it differently. So the biggest difference of this is going to be wherever we're going to use two vertex buffers is going to look a little bit like if we go to our Illumina renderer, we're basically going to have essentially what amounts to 3 draw calls, and I use that term loosely because we'll explain that here in a second, per individual geometry, right? So in this case, we are drawing the geo list, which is essentially our static or animated geometry, and essentially we call draw once on the standard vertex buffer, once on the extended vertex buffer, and then once on the index buffer. And the other thing you'll note here is the render buffer draw now takes an additional property over here. You'll see a 0 here and a 1 here, and that's a binding index, right? So we've added binding index, and that just cascades all the way down to the Vulkan layer. And so the idea here is, at least with this particular file, is if we include index data, then that means that we, according to the arguments here, we only bind to this, right? So as a reminder, the render buffer draw in the back end, actually, draw, here we go. So within our Vulkan sort of back end, we have just a bind here. So if it's bind only, then that means we only do the Vulkan buffer bind. We don't actually draw it, right? And that was just to keep from having to make 2 separate calls from everywhere, because that's kind of annoying. So Vulkan buffer bind just simply goes through and binds the buffer. Ultimately, based off the type of buffer it is, will tell us how we need to bind that. So we've made a small modification to our call to Vulkan command bind vertex buffers. And instead of hard coding a 0 here, which is what we had before, now we take in the binding index. So that gets passed all the way down. And that tells us how we actually are going to use that vertex buffer. Okay, so that's why I was saying draw in sort of air quotes, right? Because these two aren't actually draw calls, because index, including the index data here, which is going to be true, basically says that we only want to bind this, right? We don't want to actually draw it. So there's that. And then, of course, the index buffer just takes 0 because we can't have more than one of those bound at a time. So it's just kind of ignored for the vertex buffer. Or, I'm sorry, the index buffer. So that is basically the gist of it, more or less. And I've got a decent amount of this put together in terms of how the attributes are actually set up to deal with this. So that's kind of another aspect of it, is there's nothing actually in the shader that says this is vertex buffer 0 and this is vertex buffer 1 in terms of bindings. The shader doesn't actually have any of that information. It just kind of is figured out under the hood. And that's, a Vulkan thing. And so if we actually take a look at our material renderer, where we set up the attributes, has changed a little bit as well. And so a default of a binding index of 0, right? That is, let me reword that. A binding index of 0 is the default, right? So anytime we're allocating an array of attributes, it's always going to be 0. Now, to be explicit for the skin shader, I went ahead and filled it out, right? But these 5 are essentially bound to binding index 0, meaning they're going to use the first vertex buffer. And then these 2 are binding index 1, which means they're going to use the second vertex buffer. And all of that gets piped down to when we go to create our pipeline. And I won't go through all the intermediary steps because there's a lot of it, right? But if we go to pipeline creates, here we go. If we take a look at this, and I'm just going to expand this a little bit over here. Right here where we're doing our vertex input is where we actually figure all that stuff out. So essentially, instead of just having what we had before, which was sort of this hard-coded, always one vertex buffer, now we actually take a look and examine the individual attributes and try to figure it out from there. That all being said, that is basically where I got to before I had to start the stream. And we do have some errors when we go to run it. So I'm in the middle of debugging, and now you guys are caught up to where we are. Pork Nachos, good to see you. Appreciate the beard comment. Yeah, it's doing well. I'm happy with it, for sure. Needs a little bit of cleanup, I think, on the sides, but yeah, I appreciate it. How have you been? Singy, good to see you as well over on the YouTube side. From Lake, had a productive day. Awesome. Organizing a library for electric components. Tedious but productive. I get that. Totally get that. I did a bunch of janitorial type of work in a code base earlier today for work. So, just playing the old code janitor, cleaning up stuff and refactoring and trying to make cleaner and stuff like that. So all good things. Sometimes it's super satisfying. Okay, so let's take a look at the actual errors that we're getting and see if we can't figure out what the bananas is going on here. So this is during the pipeline creation, which is actually the code that we were just looking at, right? So this is create graphics pipeline. So this is within there. So create infos sub 0. Okay, well, there's only going to be one pipeline being created at a time, so that's fine. Vertex input state, surprise, surprise. Let's see, Vertex attribute descriptions format. Okay, so this is saying Vertex attribute descriptions formats, VK format undefined, doesn't support VK format feature Vertex buffer bit. Supported buffer features VK format feature flags 2. The format features of the format must contain this. Then we have a doc link. And then it looks like it might have repeated the same. Nope, it's not exactly the same. Let's see. Here we go. So Vertex input states attribute descriptions location 0 is already here. Okay, so that's interesting. So it thinks that we're defining the location 0 twice. Okay, we'll have to debug and figure out why that is. All elements of the pVertex attribute descriptions must describe distinct attribute locations. Okay, so that is a problem that actually makes sense. I'm not sure what this one means. We'll come back to that one, but this is actually one that kind of does make sense. And I should note also that shaders that are using just one vertex buffer seem to be working fine. The only one that I've actually switched to use 2 is material skinned. Let's see, and then we get a repeat of the first one. Okay, so let's see if we can't figure this one out, because I have a feeling that if we figure that out, we might actually figure the rest of it out. So let's see, did I kill it? I think I did. Okay, so let's just kind of quickly poke through here and see what we're doing. So this is where we're building the Vertex input, which is the VK pipeline Vertex input state create info, right? So the first thing that we fill out on that is a Vertex binding description count. So that is how many of these we are going to have, right? So Vertex input binding descriptions. So we essentially say if we have a Vertex binding count, because I suppose there's places where we won't. So if we have that count, then we are going to take a location count. We're going to start counting up our locations from 0. Set up an array of those binding descriptions. So Vertex input binding descriptions, right? So if we take a look at this again, it should be Vertex binding description counts. Let me peek definition on this again, just to make sure we have the right thing. So VK Vertex input binding description, right? Which is this guy. Okay. So we create an array of these. And this is basically the Vertex binding count, right? So we have how many Vertex buffers are we binding, essentially. And then for each one of those bindings, we get a convenience pointer to that particular binding. The binding index is set, right? So in this case, it would be 0 or 1. The stride is going to be the stride for that Vertex binding. This is the thing I'm not 100% sure on. I don't know whether this has to be the stride. I think this is the stride for that Vertex buffer, right? How big an element is within that particular Vertex buffer. I don't think it's the whole thing. So that's why I've switched that out that way. And then input rate is essentially per vertex. And then what we do is from that binding, we have an attribute count. Within that binding, we just increment the location count by how many vertex binding attributes we have. So in this case, it would be 5 and then 7. If we take a look at this, right? So it would be 5. And then it would be 5 and 2, rather, to make up 7, right? Dr. Elliott, good to see you. Pale Blue Zebra with a 3-stream streak. Thank you very much. I appreciate that. Appreciate the loyalty there. Good to see you. Roman General, good to see you over there on the YouTube side. You're doing overtime over there? I've been there and done that, my friend. Wish I was programming. Keep at it, bro. Yeah, I appreciate that. And good luck with the overtime stuff. I've been there, done that, got a dresser full of t-shirts, so I know your pain all too well. Could you drop your Vim color scheme? It looks gorge. Yes, I can actually do better. If I can type. That should make the bot drop a link in a second, if it wakes up. There it goes. So that is a link to my NeoVim configuration. So it's an article that I wrote on my website. And that details all the plugins I use and all that other stuff. And then has a link actually to my config. And in there you will find the color scheme. The color scheme that I'm using is it's sort of the old version of a Adwaita color theme. I branched it because they actually had changed it and it broke. So I branched sort of the old one and kind of recreated it using the newest NeoVim plugins. Using like the newer version of Tree Sitter and all that stuff. So it just works now. So yeah, it's kind of my own custom color scheme, but not completely. Recently switched to WesTerm as well with all the bindings from Tmux. Feels illegal. Yeah, I actually still use Tmux even though I'm using WesTerm just because I'm so used to using Tmux. But I mean, I guess I could do that too, but there's other things in Tmux that I like that you don't necessarily get out of the box with WesTerm. So take it or leave it. Eyeless42, good to see you over there on the Twitch side. How are you doing? Hope all is well. Okay, so binding description. So this is so these are like the top level descriptors, right? Or just not descriptor, let me not say that. Descriptions of Vertex input, right? So this is basically saying the vertex buffer that we bind to this particular binding has this stride. In other words, this is how long it is in between elements, and then how we should treat that input per vertex. And then down here, after we've done that for all of our bindings, let's see, we have a location index that we go ahead and do. And so this is where we set the vertex input info, vertex attribute description count to location count. So this is basically saying the total number of vertex attributes that we have goes here, right? And so if we take a look at this structure, we have, you know what, let me actually open that in a full window. So we have the binding description count and then binding descriptions, right? So the array of that. And then we have the attribute description count and the attribute descriptions. And so I'm not 100% sure about how I've lined this up, but I think I have it mostly right. I have a feeling I've just done something stupid somewhere along the way. So the next thing that we do is we build a sort of flat array of how all of our input attributes are. But then we also specify what binding and location we use. So we start off with location index 0. We loop through our individual bindings, grab a convenience pointer to binding config, and then within that binding config, we go through the attribute. Wait a minute. we go through the attribute count. Binding config attribute to A. So we do out attributes. I think I just found the bug. Out attributes is, yep, I did just find the bug. Because A gets reset every single time we do this. I just found the issue. Awesome. I can't index this by A. It technically needs to be. It needs to be location index, actually. We can use that. That'd be neat if it was it. I doubt that's all the problems, but let's run it and find out. I'm going to actually turn off these breakpoints just for a second. And continue. I thought I told it to turn off the breakpoints. Did I not? Okay, I'm just going to clear them all then. Fine. Hey, all right. So I didn't see any errors there. We're rendering. Now the question is, all right, well, it looks half correct. Note the complete lack of our animated models. Okay, that's interesting. So I don't think we got any errors. Let me just scroll up through here. Nope. Okay, so that resolved the validation errors. I think we need to do ye old render doc. Let's just take a capture. Okay, so forward pass, standard scene pass, meshes. I really need to rename that to models. Although I guess it is technically meshes. Sure, fine. All right, I just happen to know that these are the animated ones, right? Because they come in after the statics, right? So there's those. Okay, so this one, I do see we have issues down here, but that's not actually the problem. I want to go to pipeline states. Okay, all right, so this actually, we did fix another issue that I was seeing before, which is good. Where this vertex extended wasn't coming through. But let's see. So here we go. If we hover over this, RenderDoc gives us a nice kind of view of how this stuff is set up, right? So our vertex standard is sort of the first 5 properties there, and then our vertex extended buffer is the last 2. So we know at least that is correct. We can see the strides here. So all of that actually looks good. Byte length, I'm not 100% sure if that's right or not, but I think that's for the... Is that for the entire buffer? I'm not 100% sure. But if we go here and we just want to take a look at some of the data. Okay, so we actually have, this is what our vertex buffer looks like, right? So it's in weight, in bone IDs and in weights. And that's actually the input. So it looks like our bone IDs are correct, and I'm guessing these weights are correct as well. I have no way to verify that simply just by looking at this, but we do see a lot of these here are influenced by a single bone, and then all of these ones are all split by... Yeah, I don't know if that's correct or not, to be completely honest. That seems like the vertex weights are a little bit too uniform. Well, maybe not, though, actually. We do have a lot of pages here, so let's see. Maybe a lot of these are just affected by a single bone, and that's fine. I don't see any rubbish in here, which is a good thing. So that tells me a lot. Let me just look at these real quick. I think these are, yeah, that's like pipeline barrier issues. I'm not really worried about those. Okay. So let me actually go back to Mesh Viewer, and I'm going to actually slide this over here a little bit. Okay, so we have in position, in normal, text coordinate, color, tangent, and bone IDs and weights. So all of this looks relatively correct to me. What I'm thinking is if we take a look at the vertex in, the vertex in is like not correct. All of these vertices, yeah, those are not all the same, right? Like it's literally like collapse them all into one. Okay, so I have a feeling I know where this issue actually might be too. So let's go over to our model system where we're uploading the geometry, because there is some stuff that we have to do in here. Well, I've already done it, but when the animated mesh is loaded, which actually I really need to rename that. This should be model loaded. And we come down here, we get ready to upload everything. We go ahead and we grab the three, I'm going to close this other buffer there. So we grab the 3 buffers that we need. Those all look correct, okay? We iterate through them, and we do a little bit of a check, right? So we say if it's animated, we need to handle it a little bit differently than normal. So our geometry, and I actually skipped over this, our geometry is actually changed a little bit, our K-geometry structure. So we have vertex count, vertex element size, vertices, and vertex buffer offset. These are our standard data. So nothing has changed there other than I just added the word standard into the comments. However, the extended data is now added, and we have new fields to track that. And so we have the extended vertex element size, the extended vertices, so that's the extended vertex data, and then the extended vertex buffer offset. So the idea is that this data goes into the standard vertex buffer, and this goes into the extended vertex buffer if it is used. And so essentially what we do is just like before, we feed the vertex element size, vertex count, and vertices in here. Only now we can actually say the standard vertex size is always going to be vertex 3D. At least for models, right? We can always use just the vertex count there, and then the vertices array is just this, which actually we should probably change this to KLXC array, so we can get rid of a little bit of extra stuff here. Make that a little bit simpler, right? So that is what our common or our standard vertex array data looks like. And then if it's an animated model, specifically the geometry that we're looking at, then we go ahead and we set the extended vertex element size to skinned extended vertex 3D. So that is this second structure down here that contains that additional data. Notice that we have vertex 3D and skinned extended vertex 3D. We do not have the skinned vertex 3D anymore that included both, right? They're separate structures now. So we have that, and then this again should be a k-alloc C array. Oops. There we go. And then we loop through the source, which is going to be the K-asset skinned Vertex 3D. That is what the asset uses, and the asset does indeed have all of that stuff combined. And then we also set the standard and extended. We just get convenience pointers for those, right? So one goes to geo vertices, one goes to geo extended vertices. And we just cold cast that to the correct type and then iterate through it. Thank you for the follow, by the way. So essentially what we do here is we loop through the source vertex count, right? So the however many vertices we have in our source submesh, right? And so we loop through all of those. We grab the position, normal, texture coordinate, color, and tangent, and we put that into the target VS, which is the standard vertex data array. And then we have the extended, which is the target VE, which is the extended vertices data array within the geometry, right? So we go ahead and we set that as well. I'm just trying to determine if I've missed anything here, but I don't think so. So in other words, if we have animated geometry, we need to perform these extra steps. If we have just non-animated geometry, we can copy it sort of the old school way and be done with it. Okay. So I was thinking that the problem was likely in here somewhere. Because when we were looking at RenderDoc, all of the positional, normal data, text chords, all that stuff was just the same all the way down. So for some reason, we're not getting that data correctly. So source V is source vertices. And then source is submeshes sub I. So that should be fine. Oh, wait a minute. I see the bug. This is one of those places where if you're not careful with your syntax, C can actually bite you. Because of the whole a pointer is an array is a pointer kind of thing. This is actually treating source V like a pointer, not a array. So we're not actually indexing into that array. All we're doing is we're grabbing the first vertex out of that. So that seems fine. We're going to do source V, and then we're going to do sub V dot position, right? And so we essentially need to just do that all the way down. And that would actually explain why we're seeing the same data all the way down. I knew it was going to be like a looping bug somewhere. So that's some Dingus-oriented programming for you. Nice that we had an example there. All right, I'm actually going to close RenderDoc. And I just want to debug normally and see where we wind up. Awesome. So there's our dude animating. And now we're using multiple vertex buffers. So that actually, I wound up getting that done quicker than I thought I was going to by like a long shot, which is pretty sweet. Now that that works, what this is going to allow us to do is essentially we are going to be able to now feed all of our stuff through a single shader instead of having to branch shaders based on what kind of thing we're actually rendering, right? So where's the second slow-mo dude? Oh, I forgot to show you about that. There's another one. There's another dude here. I was playing around with some free models that I found. I found this one that was like already rigged and animated and stuff. He's doing like an attack animation. So that's just a second kind of test character. That particular character actually has, and it was a free thing that I found on Reddit, I think. But that particular character actually has, whoops, let me go to, that particular character actually comes with a bunch of animations, which is awesome for our testing, right? I wouldn't use something like that, obviously, in like the end game, right? But, we've got like a death animation, defeat, idle, jump, pick up, punch, receive, hit, roll. Like it's got a whole bunch of things that it just kind of came with, which is going to be awesome for prototyping, right? So even if it doesn't, like, if it's not the prettiest looking thing and it doesn't necessarily 100% show correctly, we can still get a lot of value out of that. So yeah, that's the deal there. Kohi Engine will be updated to include this soon. So there's a few things we have to do, right? So about 3/4 of the work that we've done is in the engine, but there's also a decent amount of application code that we've rewritten. So before I can merge 0.11, I have to convert the testbed over to doing the new way of things all the way through, because we're not even building it right now. It's so broken. So I need to get testbed up and working, but I don't want to do that until we actually have all of this stuff sorted. And then, yes, the Kohi engine will actually have that. The repo will have that, and you'll be able to run the testbed with, I'll put some examples of different kinds of stuff in there. So that's coming soon. All right, so let's go to the material renderer. And clear the highlight. So we have the material skin shader here. And right above that, we actually have the standard shader. Standard shader is going bye-bye. Ultimately, what we have, what we're calling the skin shader is what we're going to probably rename the model shader or something like that. But that's the ultimate version that we want to use going forward. So this whole thing of having multiple shaders to render the same type of material data is all kind of slowly kind of coming back together. So initialize, let me see. So we need to we actually have the material shader, material standard shader, and the material standard instance ID. We're going to remove that. We no longer have to do that. The water shader stuff is gone too. The material blended shader might also wind up being able to use the same shader, but we'll see where we land on that when we get to it. We'll cross that bridge later. Let's see. Get the binding 0 set instances for the shaders. We don't need to do this line anymore. We only need the second one, and we don't need the water shader one anymore. We can get rid of that too. And now this whole get shader for material type is animated. This is why I was like wanting to get rid of like a lot of this stuff, right? So we don't need this is animated anymore because we don't care anymore. All this is going to do is use the skin shader just like before before we started making all these changes, right? All right, so register base. Actually, do we even do this? Do I even need We do use it in the material system. Okay, so we do need to fix this one. All right, so static shader, animated shader. So we actually don't need the static shader anymore, which means we don't need this block. And then this, we don't need the Boolean there, right? So we can actually just do that. And then we can actually just rename this to shader. Cool. All right, so there's that. Let's see. Fail to acquire shader. Let's see, how do I want to put that? Binding set instance. Just update the error message there while we're in here. Okay, so unregister is going to be kind of the same deal. So we don't need the static shader anymore. That can go away. And then we can just rename this to shader. And then remove the Boolean. Okay, let's see, what else do we have in here? So, okay, so K-material render apply globals. Remember how I said I was annoyed that we had to do all this same crap twice? We no longer have to do that, right? So I'm actually just going to take all of this, delete it, delete that comment, and there we go. So we're good there. We also have the water shader globals. Let's see, we don't have a water shader anymore, so that can actually go as well. And that to-do is gone, right? So just blended shader globals if we wind up doing that. We might have like a ground or a terrain shader. I haven't really decided how I want to handle that yet, so we'll come back to that later. All right, bind base again. Let's see, we have shaders, and then we had a loop here where we had to do this whole thing twice, one for each type of shader. We no longer have to do that. So the shader is just going to go back to being state material standard skin shader. We're going to get rid of this. Actually, I should just go down here, get rid of that, then get rid of this. Right? So there's that. It looks like a lot of changes, but it's really just indenting. So material type water is going to use the skin shader again, right? We don't have the water shader anymore. So there are going to be some things we have to fix in here, but that's not a huge deal. Or at least probably in the actual overarching game renderer. So we have apply immediates, and this also had an is animated, which we no longer need, right? So we can get rid of the is animated. Simplifying our code. I like it. Love deleting stuff. All right, so there's that. Let's take a look at our Illumina renderer, because I know that's going to have some stuff in it that's broken. Oops. Let's see. So, Geo Animation ID. Right. This is apply immediates, so we don't actually need... Oops. We actually don't need that anymore, because we don't require the Boolean. And the same thing is going to be true here. Whoops. All right. I'm just going to build really quickly. Oh, that was quick. All right. I didn't think that was just going to work right off the bat. In fact, I don't think it's going to work right off the bat. I think it's probably going to throw some errors at us. But let's run it and see. Yeah, I thought so. Okay. So I have a feeling I know why this is too. We didn't get any errors for loading anything, but let's take a look exactly what caused this. Really? Writing texture data? Okay. That's interesting. I'm just going to restart and see if that was maybe a fluke. Because I don't know whether it was or not. Yeah, it was a fluke. Okay. All right, so let's go ahead and load this. Not so much a fluke. Okay. Okay, well, I have some suspicions around what the problem might be. So we'll take a look at that. In fact, there's a few minor changes we're going to have to make to our shaders to indicate what the heck we need to do when it comes to our shader data. So let's take a look at when we go ahead and render. Let's see. We want... Yeah, we're going to want geolist, draw geolist. So this is always doing a draw here, which is fine. That should always be doing a draw there. I could have swore we had to actually like change that up somehow, but maybe not. So we need some sort of way in our shader to say, hey, we're animated or we're not, right? And I guess we could probably look at instead of doing all this bone transform stuff, we could probably look at bone IDs and see if any of them are -1. Because I think they are signed integers, if I remember correctly. Yes. So we might be able to go that route. Although our weights should also be not set to anything. So let me think. Is that going to work? I think we'd be better off just bypassing this logic, honestly. So if we had something like an input, like a geometry type, for example, where we could say we're drawing stuff that either uses this data or doesn't. Theoretically, we could either branch this code, or it might actually be faster to avoid the branch and actually just have like a 0 in there for if we included a geometry type of 0 for static data, then that would essentially, well, that would zero this out, which is not actually what we want. Actually, what's the, I can't remember the GLSL identity matrix. I think it's literally just mat4 1.0. What I should do is mat4 1.0, right? Start with an identity matrix, then do bone transform plus equals this, right? And then if we have up here in, let's see, I think this is probably going to have to be a per draw type of thing. It doesn't make sense to put in there. Materials doesn't make any sense to put in there. Not in there. Yeah, it's going to have to be our immediate data. So we do have padding here. So we could do uint geotype, right? And we can say 0 equals static, 1 equals animated, right? And then this gets cut down to a vertex or a vector 2. So if we're going to have to take this and go to the fragment shader. And do the same thing. So right here, we'll do that, right? It doesn't matter as much here, although that means I could actually eliminate this, which might be a better thing to do. Let's do that. Let's get rid of those out of the DTO, and then here we can just do immediate. Right, maybe that'll work a little bit better. And then go back to here and remove this out of the DTO from here. And then we don't need that. And then here, what we can do is, since this is additive, we can actually get away with the 0 in multiplication, right? So we can do immediate dot geotype, right? And we can just do, oops, do the same thing over and over again. And that will essentially keep us so that we don't have to, essentially when we pass in the geotype, we're essentially ignoring the bone IDs and the weights. And then it shouldn't matter what we're doing, right? So, okay. Let me look back at the Illumina renderer. And let's see, I could have swore that we had, yeah, our immediate data here. Right, so for this, we did have some, what do we have in our apply immediates? Yeah, it was, whoops. This. So we would have to, in our renderer immediate data, we have to make the same change. So U32 geotype, and then padding. And here, geotype equals that, right? So let's see. This is the, oh, this is the water plane. Okay, so actually for this, you know what I'm going to do? I'm going to actually copy this line, paste it for a second, and here I'm just going to do that's static geometry, right? And then I'm going to take this and go to immediate data. Shadow pass is going to be another thing we're going to have to tackle in a bit. Let's skip that for now. And here we go. Okay, so draw geolist. So each geometry. And then that should do what we need. Let me do K material render immediate data. That'd be a more accurate search. Okay, so there's only 2 places we do that. So maybe that will get us through. Let's see. So if you have extended vertex offset and vertex count. Oh, it probably doesn't like... Well, no, vertex count would never be 0, so that shouldn't be an issue. Extended vertex offset could be 0, but if we're ignoring it, who cares? Oh, this one might actually be the problem. So we actually do need to do the same thing here. Since this is using the same shader, we can actually say the vertex buffer offset is just 0, right? And then the vertices is 4, fine, whatever. And then this needs to be index 1. Let's see. Let me catch up on some chat. Recommended a C programming book a couple of weeks ago. Was that C programming language 2nd edition? I think it's 2nd edition. Yes, it was. Yep. Also, do you have any recommendations on learning GCC Clang compiler usage? Just thinking about reading the docs from the beginning. I haven't done that, but yeah, I look stuff up on there all the time, just kind of as I need it. So no, I don't have any direct advice there, but their documentation is pretty good. So at least for Clang, I've been using Clang for quite a while, and the documentation is pretty good on that. I can't speak for GCC because I switched away from that for a while ago, but even that, the documentation is decent. Recently started a small render engine in OpenGL and Odin, which was really fun, but thinking about starting over in C. I mean, do it, right? If nothing else for the challenge. That's what I say. What was the reason for switching to Clang? Cross-platform support, frankly. It was very easy to get Clang working consistently on Windows, Linux, and macOS. So it's just kind of what I went for. And at the time, it was kind of kicking GCC's butt. Okay, did I build this? All right. Let's see if it does anything this time around. Not looking promising. Okay. So what is causing interesting it's doing it on a texture upload, but I think that's just a red herring. I don't think that's what the actual problem is. So ever since we switched to using the same shader for everything, it just doesn't seem to like that. So why would that be? So that's water planes. Oh, well, let me check the model system real quick. Did we have anything in here So we only do extended vertices if it's animated, which still does make sense. Oh. This is going to be 0. It probably doesn't like that. That's probably what it is. It probably does not like that. Okay. But wait a minute, though. We only use that to either upload or free from that buffer. That's literally it. Those are the 3 uses right there. So I don't think that's actually... Yeah, it's literally just used on those 3 places. Okay. So the upload... The upload not happening shouldn't matter, because even if we do bind that shader, or do bind that Vertex buffer with just 0 offsets, it should still work. All right, let me try something else. Well, before I do that, let's see, draw. Actually, it should be underscore draw. See, this doesn't even necessarily matter, because that could be 0, but that's still technically valid within the buffer. So we use standard index 0, and then we use extended at index 1. And that worked before. So what is causing this to completely poop itself now? Let's see, scene pass. Okay, so this is the skybox. So that's irrelevant for the skybox. This is for the water plane. So again, we just bind rubbish here and forget about it. That should be fine too. This is each geometry. Did I really loop back around? Weren't we just looking? Oh no, it's separate. Okay. Okay, so we do, this is for what? Each mesh geometry. Oh, is this a shadow pass? That might actually be wrong for right now. Yes, this is a shadow pass. So that's actually wrong for right now. I'm going to put a fix me in here though. Whoops. Enable this when updating the shadow shader. Okay, so that one should probably be disabled for now. Opaque geometries. This is going to be the same thing. Wait a minute. Yeah, this is going to be the same thing for the shadow pass. So, same thing here. I'm going to copy the fix me here as well. Probably ought to feed these into a routine or something so that I don't have to have two different ways of rendering it, but here we are.
You dingus?
Dingus indeed. Height map terrain. Okay, we're not doing these yet, so I'm not worried about that. And then this is debug data, which doesn't need that. And then this one is the editor gizmo, which also doesn't need that. And then this is all UI stuff. Okay, maybe that will fix it. Because the shadow map buffer does not take... Or the shadow map shader, rather, does not take 2 vertex buffers. Thank you for the follow, by the way. Nope, that hasn't fixed it. I wish it would give me like a validation error, some sort of something to tell me where it's failing. I probably should have like committed before I made all of the changes, removing the other shader. 3D Code Warrior, good to see you. Hello. It is interesting that it seems to stop at the same place every single time. Let's actually look at the logs a little bit closer here. All right. Move this over. Okay, so here's all the default textures getting set up. Default materials, bitmap fonts, system fonts. ItemDB. Let's see, shadow. Okay, so this shader loaded fine, this shader loaded fine. Actually, it looks like all the shaders did. Okay, so shaders loaded fine. Then we load the zone, load the skybox, attempt to load base character, and dancing vampire. So those are our animated ones, right? Model loaded. Okay, so materials for skin and face. Those I happen to know is with the base character. We kick off the material load. We set up the animations to run. Okay, that's the tree coming in. Vampire material. Yep, that's the dancing vampire. So that's fine. Playing the animation there. Okay, so this is going to be loading the orange 512 that we have on the blocks. Again, this is going to be another tree, another block, vampire, I think that's another tree, vampire mission. Okay. And then orange lines 512 emissive is where it fails. And I bet I could run this again and get the exact same result. Yep. Okay. So let's switch gears. I'm going to actually turn some stuff off in the level and see if that can actually help us. So let's go to this, and I'm actually going to use this editor for it because I need a bunch of single line comments. Excuse me. All right, so I'm going to turn off. I'm going to turn off the type of model for this one. Oops. And then none of the other stuff will be red, right? So I'm just going to treat that as if it's an empty one. And then I'm also going to turn off model for this one. See what that does. Nope. So it might not be the animated ones, it might be the static ones causing the problem. Interesting. Well, I guess that kind of makes sense because those are the ones that have the change in shader now. So I guess I could go through and turn those off instead. Type equals model. Right, so player mesh, I'll leave that one alone. This is test cube, so I'll comment that one out. This is tree, whoops. Tree. So I'll comment that one out. And another tree. I'll leave the test animated model. I'll leave the animated ones at least for now. Okay. So I think the only ones that are active still are the animated ones. So let's actually see if that loads up. I might have to turn the water off too, actually. Yeah. Let's see. Vampire mission. So that doesn't seem to matter what it is. It's just failing on textures. Okay. It's definitely an interesting one. Oops. Let's see. Where's the water? Let's also turn that one off. My theory is correct. So it's the static ones screwing things up. It's anything using static geometry is messing it up. Right, because our two animated things are here. Interesting. Okay, so why would that be? So animation ID being invalid is the only differentiator. Somehow I don't think that's the problem. And it's not even... Let's look at the scene real quick. So if we start with the water first, in fact, I'm actually going to go to 0, 0. I'm going to go here, and I'm actually going to re-enable the water plane. See if we can't get this one to work first. So this one allocates just regular Vertex 3Ds. And then index buffer. Vertex offsets. Right, so it's from the Vertex standard buffer and the index standard buffer. And then we upload the data accordingly to each. So that should be fine. So what happens if I then, when I'm setting up the geometry, so if we do new geo, extended vertex offset, and we set this to, I don't know, 4, and then do new geo, actually I think that's all we can set. Let's actually do this. Let's do size of Vertex 3D, right? Just to give it something. I don't know that that's going to be valid, but nope. Hung again. Okay. So let me think. What could possibly be doing that? And like, this is one of those things that like the Vulkan validation layer should be catching this. Get default water. All right, let's, this is absolutely asinine, but let's try something really stupid. Let's do extended vertex buffer. Let's upload some data to it, right? We shouldn't have to do this, but here we are. Oh, you know what? All right. Should not have to do this. I don't think this is actually going to be the problem, but we'll try it. Extended vertex buffer. Right, so we'll try putting that there, and then also in the Illumina renderer, draw the water planes. Here we go. So geotype is 0. Oh, we are already doing this. See, the idea is that we should just be able to do this no matter what. and be fine. We should just be able to call both with whatever this binding is because we're kind of ignoring it. Interesting indeed. So when we draw this one, we should do bind only on it. Let's see, buffer offset is 0. Element count is 4. Binding index is 1. So why would that fail? It obviously works for animated ones. What am I missing? This is going to be something very stupid, I have a feeling. And then that's all, let's see, shadow pass. Oh, I wondered if, oh, you know what? I wonder if it is. I wonder if it is the shadow pass shader or the shadow shader. Because this doesn't get called for animations, but I wonder if it is this shader. I wonder if that's the problem. Shadow pass. Because we hadn't added animated meshes to work with that. And I wonder if the new Vertex format is somehow screwing this up. It shouldn't be. But I wonder if it is. Can I... Let's see, can I do... Is it going to allow me to do this? I don't know if I can actually successfully do this. Or if it's just going to barf horribly. Nope. So we've completely disabled that pass and it still does it. Okay, so it's not the shadow pass. I mean, that's valuable information. All right. Well, forward pass. Oh, I wonder if, did we miss it anywhere in the, let's see, scene pass. So this is what, the skybox. That wasn't the problem. material globals. None of these are actually going to get done until we have the water planes here. What happens if I flip this to 1? Still poops itself. Okay. So that makes me wonder if it's like something going on with the upload then. Sweet. Okay. Well, unfortunately, for tonight, I'm out of time. I know we got started late, unfortunately, but you know, we did have a longer stream last night, so it is what it is. I do have to get up for work in the morning. So I'm going to have to leave it here for this stream. We did make some progress, though. We do have our sort of dual vertex buffers working. It's just for some reason any static geometry rendering doesn't seem to want to work. So I'm going to find somebody to raid. And I want to just give a big thank you to you guys for joining me. Really appreciate it. And let's see. Let's find someone to raid. Actually, I think I see who I'm going to raid. Yeah. We're going to raid Falonier. See what he's up to. All right. So thank you guys so much for joining me here tonight. I really appreciate it. If you haven't already, if you're new here, I would really appreciate the follow and or the sub on YouTube side, or both if you're so inclined. I am trying to grow the channel, but yeah, thank you guys so much for joining me. And let's see. Oh, I don't know how to pronounce your name, but Kaya, that's how I'm going to say it. Hello. You actually happened to come in right as we're ending the stream, but did want to just say hello to you. So yeah, anyways, that's going to do it for tonight's stream. We will be back at the next regularly scheduled stream next week. So see you guys later. Thanks again for joining, and yeah.